Hello guys, welcome to my YouTube channel Civil 3D for Professionals by Sunit Tushara. Today I'm going to teach you how we can enter superelevation using an automatic method. Actually this method was developed by me using a piece of micro enabled Excel sheet, right? So you can use this method. If you want this piece of software, please comment your email address in the comment section. So I'll going to give away for free for anybody who requests. We'll go to our lesson today. Now uh, we have an alignment already created. We'll open it. Now even though that super elevation thing is being developed for uh, the alignment, we show that in the profile view. Okay, that is how we do that in Civil 3D, right? So first we have to have kind of a profile. Now we'll see. Right, now this is our alignment we already created in our previous lessons. So you can create the profile view here. Profiles, create profile from surface, DCL. Here we give EG, that is our existing ground. This one, of course, is NS. If you want, you can of course delete it. Okay, that is the default one. Depending on this template, it has nothing. Okay, so you can remove it. Now we can create the profile. Create profile from surface. Yeah, you add it here. Drawing profile view. You can give a name. Usually we give EG, existing profile. Profile view style, of course you can select depending on your preference. Usually I give road FX, then go to next. This is station range, nothing to change. Profile view height also we are not going to change. Next. Profile display options also we are not going to change. Next. Data bands, so you can go to highway design. Here check whether you are having here you have super elevation data, right? So go to next. And profile has options, you don't have to change anything. Create profile view. So it says select profile view origin. Select some place, a convenient place here. So you can see this is your, here they give horizontal geometry, cut field depth, design level, existing level, change. If you really want to change this order, you can change it by saying, say, profile view properties here. So you can see, say we'll take chain edge to the top. Select it. Using this one, you can take the chain edge top. And then say horizontal geometry, we'll take it down. Horizontal geometry and super elevation data together. Okay, you then apply it and press OK. So here you have this is the chain edge and this is horizontal geometry and this is super elevation. You see the super elevation is empty, right? So how can you give super elevation values? Now I'll show you what is the method usually adapted by Civil 3D is you can go to this say sites, site 1, alignment, centerline alignment. This is your alignment, right? You select it and then go to edit super elevation. So you can go to calculation super elevation now, right? So you can give the method. Okay, usually our road is undivided ground, right? You can go there. Lane width you can give. Normal lane slope, usually our one is minus 2.5. Okay, it doesn't consider that. Okay, so keep it like 3. And then normal shoulder width, our one is 1.5. Normal shoulder slope, we'll keep it as it is. Next. And this is the super elevation development methodology. This is mostly this is okay according to Ostrots. So you finish it and then check what has happened. This is your super elevation table. Now you can see this is how they create the super elevation, right? Can you see that this is a mess? Okay, this is almost a mess here, because you see so many super elevation values here, so many super elevation values. This is the reason is here. Now you see they do not consider here the compound curves or reverse curves. They consider each curve uh, as an isolate curve. So this is a problem. So we'll remove this here. You can right click, edit super elevation, tabular editor. Then using this one, this tool bit, clear all super elevation data, you can remove everything. Okay. Is it gone? Ah, yeah, gone. Sometimes it takes time. Okay, now no super elevation. So how can we calculate our super elevation? For that, I have developed a small piece of software. This is of course a macro enabled Excel sheet, right? Here you open it, you go to this RD1, that is raw data 1, right? Then you come back to Civil 3D. You select this alignment and right click, go to edit alignment geometry, and then you select this one, alignment sub entity editor, sorry, here this one, alignment grid view. Here you right click here, right click, copy all, and then you come to this piece of software, and in RD1 you paste everything, and then close this one, close this toolbar, and then you go to toolbox, and in the reports manager under alignment, in alignment curve, you double click it, and you should make sure that there is only one alignment is selected, because of course we created only one alignment. Otherwise if you had so many alignments, this will be a problem. So you have to untick all other alignments that you don't want. Okay, press OK. Then we can save this here. Study Civil 3D super elevation. You save it. Okay, then you will get the alignment DCL parameters. Okay, so you select Control A, Control C, select all and copy, and then you come to this Excel sheet, come to RD1 raw data 2, and in A1 cell you copy everything. Okay, then you come to data and press this extract data button. Okay, now it automatically takes whatever the data it wants to calculate super elevation. Here radius is taken, start chain is taken, end chain is taken, and the direction of the curve is taken. So you go to this design tab and you give here your requirements. The lane width, usually our lane width is 3.5 plus it says include lane width plus hard shoulder width. Okay, hard shoulder is 1.5, so it is 5 meters both together, right? Number of lanes per one side, it's 1. It can be 1, 2, or greater than 2, or 1 is 1. So our uniform design speed will give like 50. Proposed uniform LE, here you can keep it as 0. The thing is now sometimes if you are going to give a, like say here in this first curve our LE is 39, right? In the second curve LE is 36. Now in the third curve LE is 36, right? But just think that sometimes if you want to keep it as a you are going to give in some roads, you can give a higher super elevation development length than what you calculate here, right? If this is such a value, say 42, right, then everything becomes 42. Otherwise if you don't want, you are going to take the calculated value, keep it as 0. So this is the value calculated. Then maximum super elevation, that you can give whatever you want, 4, 5, 6, 8, 10. So depending on your design standards. So since this is in a flat terrain, I'll keep 4. Area type, it should be either open or built up. So I give built up, right? Remember then this changes. Okay, if it is a If it is open, these things going to change. If it is built up, the calculation is going to change. So this one you keep empty and then calculate, press calculate button. So it will calculate and an output tab will be generated. Here this is our output. This is the superelevation calculation. So you go to file, save as, and save 3D superelevation. You have to save it as CSV comma delimited. Okay, CSV comma delimited, then you save it. Okay, press OK, then press OK, remove this, don't save. Okay, right, then here, okay, you come back to this prospector, select this DCL, right click DCL and right click and edit superelevation. Here instead of calculate superelevation, now you go to open the superelevation curve manager, right? Then go to this tabular editor and then here import superelevation data from file to import. You select check whether this one is your one, study, CLTD, superelevation, yeah, this one. Select this CSV, press open and then press OK. So it asks some of all the data you are importing does not match up with the curves in the drawing. So ignore this. No, don't ignore. Press accept all data. Okay. Right. Now tick this and close this. Go to view, region. Now you will see here this is your proper superelevation calculation and proper superelevation diagram. Now can you see here? This is the superelevation development length, and look here, now this is a closely spaced compound reverse curve. So they have taken the middle of it as the level crown. Okay, so this is a very proper superelevation development. So this has been done based on the Sri Lankan standards, but of course I'm going to give away my Civil 3D my superelevation development Excel sheet for free. So you can go to its code section and then change whatever you want to match with your standards. Okay, right, then thank you for watching. Please subscribe my subscribe my YouTube channel and press the bell icon for videos like this. And if you want my Excel sheet, macro enables Excel sheet, you can comment your email address down. So whoever that comments the email address down, I'll email this piece of software for free. Thank you very much.